This call is now being recorded.
All right. Hey, it's Algebra 1. Exciting day. Module 1, Lesson 19. The title of the lesson is Rearranging Formulas. Today, we're actually going to be practicing the same skills that we've learned before as far as solving equations, except we're going to be solving equations that have just letters in them. And so we're going to review and scaffold our way, in other words, inch our way towards understanding a concept that looks confusing, but it's really not. So let's start with our Lesson 19 book and the Eureka Math series. They do a really good job with this lesson in terms of organizing it and approaching it from a very simple point of view. So let's start with exercises 1 through 3, and we're going to do those together in class. So say, as I do these problems, you're going to do them on the screen or on your in your notebook. Here we go. So the first thing is, it says, always read the directions. Always read the directions. It says, solve each equation for x. For part C, because there's going to be A, B, and C. For part C, remember a variable symbol like A, B, and C. They represent a number. Could be any number. And so A and B should be very familiar. Let's do A and B. A and B, we should have no trouble because we've already learned the basics of solving equations. And there's nothing hidden there. Basically, what you're doing is you're trying to isolate the x variable in letter A, and you're using our principles of what we do on one side, we do on the other. The addition property of equality, the division property of equality you see in red, and then you have your answer, x is equal to A. Move on to B. Same type of deal. There it is. This is review. Then they provide for you what it looks like is a totally different problem. Completely different. AX minus B is equal to C. Like, what is that? Well, if you look closely, A was 2 in the first problem. B represented 6 in the first problem, and 10 was C. In the second problem, A was -3, B was 3, and C was -12. They're just plugging different numbers in, and they're saying, okay, now in C, let's solve for X, not knowing exactly what A, B, and C are. And you're going to see something, and I want you to notice. This is exciting. Pay attention there. What does that give us? But you can't combine C and B. You represent that move by saying C plus B. You could also write it B plus C by the community property. Last step. What do we do here? What do we do here? We divided by an A. Answer, C plus B over A. You can't do anything with that. You could also write it, you could also write this as B plus C over A. Either one, either answer is correct. It doesn't matter. Because of the community property, C plus B is the same as B plus C in the numerator. And that's it. You can't go any further. You're done. The stun looks on the faces in front of me. It's quite incredible. How did you make this so simple, Mr. Kendrick? And so, well, it's what I do. It's what I do. It's what I do. Ready? Next problem. Number 2 says, compare your work in parts A through C. Did you have to do anything differently to solve X? No. We didn't have to do anything different. Nope. because you're doing the same exact thing. It's really important that you see that. So you're doing the same exact thing there in number 1. And so the process to solve all 3 equations is the same. So the answer to number 2, the process to solve all 3 equations is the same. The process to solve is the same. Okay? All right, move on to number 3. Solve the equation ax minus b equals c for a. Uh-oh, same equation, except what did they change up? Well, they changed up the letter that we're solving for. So now we're solving for a. Okay, so I'm going to rewrite this. Now we're not solving for x, we're solving for a. So let's do it. We're going to do the same thing. Do the same thing. Got to get that by itself. Remember, we're solving for a. Really important to understand that. And so I have ax is equal to b plus c, alphabetic order sometimes. Then, instead of dividing by a, I divide by x. And so a is equal to b plus c over x. Believe it or not, that's it. You're done. Pretty simple. Raise your hand in the class if it's simple. Okay. All right, so let's keep going. We're almost done. Believe it or not, we're almost done. So then they start talking about, well, what else can we do with this? Well, we can apply it to context problems. For instance, we should remember that the formula for area of a rectangle is length times width. And so we're going to work through this exercise here and then hopefully wrap this up in just a few minutes, because this is really what we're doing in lesson 19. We're rearranging and solving for different variables. So let's take a look at this first example. The area of A is equal to 25 inches squared. The formula for area is A is equal to LW. If the width is 10, what's the length? Well, we know that 25 is the area. We are trying to say, well, W, so here's L and W. We know that W is given to be 10. What's L? We'll divide by 10. And the length is 2.5. If the width is 10 inches, what's the length? Well, the length is 2.5 inches. What's the width W? If the width W is 15 now, what's the length? Well, let's take this out. If the width is 15, now we're plugging in 15. Oops. Plug in 15. Divide by 15, and what do you get? So, 25, take your calculator out, divided by 15. .6 repeating. 1.6 repeating. You could also reduce this fraction. And so this as a fraction is 5/3, also known as 1 2/3. These are all the same answers. Okay, so keep going. Rearrange the area formula to solve for L. Okay, so in the first time we put 10 inches for W and solve for L. Then we put 15 in for W and solve for L. Now they're saying solve for L generically. And look, right here, they divided by W. Right here, divide, and what do you get? You get A over W is equal to L. So now we have a new formula. Basically, you now can create formulas. If the area formula is right, well, let's verify this. If the area is 25 and the width is 10, did that equal L that we found out? Yep. If area is 25 and we plug in 15, does that equal the length that we found out? Yes. And so we verified that. Okay, we're going to do one more problem. Going to do one more problem here, and then we're going to be out of time. I'm going to go to number 5 in your book. I'm going to jump forward here. So we'll come back in class and do the number 4. Rearrange each formula to solve for the specified variable. Assume no variable is equal to 0. So let's do A, 1, and 2. Here we go. Solve for P. Solve for P. Take this and solve for P. Watch. So I rewrite it. RT. It looks complicated, but it's not. We're solving for P. Guess what? Just divide. This is so easy. It's unbelievable. And P is equal to the area over 1 plus RT. Believe it or not, that's the answer. Believe it or not, that's the answer. You got one more and then we're done. Okay, last one. Don't make these hard. Now, if you distribute through, you'd be causing more problems. And this one, you got to be really thankful. What's going on here? So here we go. T, solve for T. Write the original. Now, this one's going to require some work. This one, I have to distribute through. I must distribute through. P, R, T. So I'm solving for T. That means I'm going to subtract P. I'm going to move my work up here. And I get A minus P is equal to. A minus P, not like terms. I got to keep them separate. That left me with P, R, T. And then, last step, divide by the P and the R. It's multiplication. And guess what? My answer is A minus P over PR is equal to T. Now, I can't cross these out. I cannot cross the P's out because of the subtraction sign. Because of the subtraction sign, I'm done. That's the answer. That is the answer. Let's see here. There's another way you can write this, which we'll talk about. We can write this a couple different ways. This is one way. All right, that's going to conclude right now. We're going to do some more work on lesson 19. But this is really all it is. Rearranging, solving for different variables, but we're using the same skills that we use to solve equations. That'll do. Talk to you in a bit.